Hi, welcome back to Chem2 channel. I'm Jepu Wong. Today we are going to look at SBP Trial Paper 3. Let's start. Today we are going to look at SBP Paper 3. A group of students conducted experiment in the lab to determine the heat of neutralization. Okay, for the reaction between the acid and two different types of alkali. Okay, so the following are the procedure that have been carried out for the students. So set number one, the step one, okay, 50 cubic centimeter of 2 mole per cubic decimeter hydrochloric acid. Measure and pour into the polystyrene cup. Okay, then step two. Same volume concentration of potassium hydroxide solution was measured and poured into another polystyrene cup. Okay, a thermometer is put in each polystyrene cup and thermometer reading is taken. Okay, and that potassium hydroxide solution is poured into a polystyrene cup contains the hydrochloric acid, and then the mixture is stirred using a thermometer. And after a while, the thermometer reading of the mixture is taken. Okay, then step 1 to 5 are repeated by replacing the potassium hydroxide solution with ammonia. Okay. So now, okay, for this experiment, okay, state the manipulated variable. So just now we know that the manipulated variable, or we manipulate the variables that will be using different types of alkali, right? So here, okay, so you can write, okay, type of alkali, or you can list out. This now is potassium hydroxide, right? Okay. And ammonia. Okay, so this is the manipulated variable. Next, for responding variable, okay, very easy, will be heat of neutralization. Okay, then in this experiment, the fixed variable are volume and concentration. Okay, this one can be comes together of alkali. Okay, or you also can write and polystyrene cup. Okay, so now state the hypothesis for this experiment. Okay, so just now we know that our MV is the type of alkali, right? Okay, then our RV will be heat of neutralization. Okay, so we can make a hypothesis like this. Okay, so hydrochloric acid reacts with sodium hydroxide. Okay, solution to produce higher heat of neutralization than the hydrochloric reacts with ammonia. Okay, so here we can see hydrochloric acid, okay, reacts with sodium hydroxide. So sodium hydroxide is a manipulated variable. Responding variable will be heat of neutralization. So responding variable must come after the manipulated variable. So higher is the direction. Okay, so ammonia is another MV. So make sure that you can write the hypothesis correctly. Okay, next we look at experiment 1. Diagram 1.1 shows the thermometer reading for the reaction between the acid and the potassium hydroxide. Okay, so before mixing and after the mixing. Okay, so here is given you to the space to record the initial temperature and the highest temperature with the temperature change. Okay, now we look into the diagrams here. Actually, the diagram is not very clear. Okay, not very clear. Okay, so here this one is a thermometer. Okay, inside this, okay, actually this one is 20. Okay, this one is 30. So between the 20 to 30 degrees Celsius here, there are 10 scale. So each scale is referred to 1 degree Celsius. Okay, so in paper 3, we need to determine the accuracy of the reading. So how do we get how many decimal place? So normally we will use the smallest scale divide by 2. So you will get 0.5. So meaning that all the readings you get from the table or from the diagrams here, you need to put 1 decimal place. Okay, 1 decimal place. So here is roughly is 28. 28. Okay, but in the exam will be clearer. Don't worry. So this one will be 28 degrees Celsius. Okay, so here the temperature of the hydrochloric acid, you have to write 28.0. Okay, then how about this one? Yeah, almost the same. It also 28. Okay, 28.0. Okay, then how about after the mixing, the highest temperature you get is roughly is 40. This is 40. So this is 50. So roughly is 41. Okay, 41. So it's 41.0. Okay, yeah. So here, how to get the temperature change? Okay, for this case, both initial are the same. So it's 28 plus 28 divided by 2. You get 28 also. So the temperature change will be 41 minus 28. So you get 13. Okay, so 13.0 degree Celsius. Okay, so remember, if your data here you miss out the 0.0, you'll be under score 2. You cannot get score 3. Okay, now experiment 2, using the ammonia. So again, this one is 28 also. Okay, this one also 28. Okay, so initial temperature all are the same. So 28.0, 28.0. Okay, then how about this one? Okay, this one is 30, 40. So it's roughly 39. 39. So 39.0. Okay, so temperature change, initial the same. So it's roughly 11.0. Construct a table to record the initial temperature of the solution. Okay, so initial temperature, highest temperature, and then the temperature change for both experiments. So you must construct a table. Okay, so here suggested. Okay, so normally we'll draw a table. Okay, now we have set. Okay, set 1 and set 2. Okay, and after that, okay, initial temperature of acid. Okay, so degree Celsius. So for set 1 is 28, set 2 also 28. So initial temperature of alkali. Okay, unit must be stated now, also 28. Okay, then after that will be highest temperature of the mixture. Okay, so for highest temperature of the mixture, okay, this one is 41. Okay, then for set 2 is 39. Okay, then finally is temperature change. So this one is of 13.0. Another one is 11.0. Okay, so this is how we draw a table. Okay, then score 3. Remember, all the unit must be stated correctly. Okay, try not to write your unit in the data like this. Okay, so no. Okay, now based on the experiment 2, state 3 observation and 3 respective inference. Temperature increases from 28 degrees Celsius to 39 degrees Celsius. Okay, so based on this observation, why the temperature increase? Okay, so inference is, so this is an exothermic reaction. Okay, so next one, okay, so colorless solution will be formed. Okay, so colorless solution is formed. Why? Because the salt is formed. Okay, the salt will be the ammonium chloride. Ammonium chloride. Okay, then another one. Okay, you can say ammonia. It has a pungent smell, right? Okay, so another observation will be pungent smell. Okay, disappear. Okay, disappear. Okay, why? Okay, why it is disappear? Ammonia is neutralized by acid. So this is how we can state operational definition. Okay, again, operational definition. A lot of students afraid of this question. So operational definition, what you observe and what you do, OD. Okay, what you observe, what you do. Okay. Okay, so what you do or what you observe, okay, we can actually modify the definition for the heat of neutralization. Normally, if heat of neutralization will be the temperature change when 1 mole of water is formed from the reaction between the acid and alkali. Okay, so actually what is observed here is a temperature rise or temperature increase. Then what you do in this experiment is acid is added into the alkali to form the water. Okay, so here we can write, okay, you just arrange your sentence. Okay, so what you or do or observe, you can write either one first. Okay, temperature rise, okay, when acid react with alkali to produce, okay, 1 mole, we have to mention 1 mole of water. Okay, yeah. So normally if the heat of reaction, we just change the temperature change, we change to temperature rise. Okay, when the something the back ones remain the same. Okay. Then calculate the heat of neutralization for experiment 1. For experiment 1. Okay, so for experiment 1, okay, is acid, hydrochloric acid with sodium hydroxide, produce sodium chloride and water. Okay. Then just now we know that the volume and concentration given are the same. There is 2 mole per cubic decimeter for both acid and alkali. Then volume will be 50 cubic centimeter. So both are the same, acid and alkali. So first one we can calculate. Okay, number of mole. Okay, for acid or alkali the same. We use the mv over 1000. Okay, m is 2, V is 50 over 1000. Okay, we will get 0.1 mole. Okay, this one is for acid and alkali because the same. But if they are different, so we have to choose the smaller number of mole, which is the limited one. Okay, after that, okay, Q equals to mc theta. Okay, the m is the both solutions of 50 plus 50. C is 4.2. Okay, theta it will be 13. Okay, so we use our calculator. Is roughly 5460 joule or 5.646 kilojoule. Okay, this is Q. Okay, then after that we can calculate the delta H. The Q over the mole. Q is 5.46 over mole is 0.1, so it's 54.6 kilojoule per mole. Okay, then finally we can write again heat of neutralization is minus 54.6 kilojoule per mole. Okay, this negative shows it is an exothermic reaction. Okay, heat is released. Okay, H. The experiment is repeated using the solution R and solution X. Okay, diagram 1.3 shows the pH meter reading for each solution. So here is 10.5 is roughly is a weak alkali. Okay, 4.5 is a weak acid. Okay, then use the same volume, same concentration. Okay, predict the temperature change. Okay, for the two solutions when they mix. Okay, so we can predict if just now the strong acid with the weak alkali, the temperature is roughly is 11, right? Okay, so here we can put, will be lower a bit. Let's say we put 9 degrees Celsius or put 10 degrees Celsius. Okay. Now nitric acid is a strong monoprotic acid. Okay, state the relationship between the type of alkali and the value of heat of neutralization when react with nitric acid. Okay. So we can mention relationship between the type of alkali. Okay, so we can mention nitric acid reacts with strong alkali to produce higher heat of neutralization. Then acid nitric reacts with alkali. So this is how we write the relationship. Next, table 1 shows the value of heat of neutralization of some alkali when react with hydrochloric acid through the experiment conducted. Classify the following alkali into alkali that ionize completely and alkali that ionize partially. So completely will be strong, then partially will be weak. So you can see if the theoretical one, if strong acid with strong alkali, the heat of neutralization is roughly 57 kilojoule per mole. So if close to the theory one means strong acid, strong alkali, this one and this one, W and Z. If less than 57 kilojoule per mole, meaning that it's a weak alkali. So it's a weak one. So here we can classify them. So type of alkali. Alkali that we can make a table like this. Alkali that ionize completely. Another one will be alkali that partially. So here we know that completely will be W and Z. For partially, for the weak one, be X and Y. So this is how we classify normally. Question number 2 is the planning of experiment. So diagram 2 shows a conversation between two students. Two students about observation at anode after an electrolyte of sodium chloride solution. So the student A, I electrolyzed dilute sodium chloride solution and found that the gas released at the anode ignites the glowing wooden splinter. This one you have to know this is the oxygen gas. Then another student say, when I use the concentrated sodium chloride solution, the gas released turns the moist blue lemon pepper to red and then it is bleached. So you must know this is a chlorine gas. So based on the above situation, plan a laboratory experiment to investigate the effect of concentration of sodium chloride solution on the product form at the anode during the electrolysis. So your planning should include the following aspects. These are the standard one. Problem statement, variables, then hypothesis, and then list of material apparatus, and then procedure, finally tabulation of data. So normally, this one will be 2 marks. The others are 3 marks. 3 marks. So total is 70 marks for this question. So let's try. Okay, so first one, okay, what is the problem statement we can write? Okay, so we can ask, does the different concentration of okay, sodium chloride solution, okay, affect the product, okay, affect the product form at anode. Okay, yeah. So here actually we can see so concentration of the sodium chloride is the manipulated variable. Responding variable will be this one. Okay, so normally we just manipulate the MV and RV. It looks like the hypothesis, right? Okay, next. Okay, next one would be variables, right? Okay, now variables we have manipulated variable. So variables we have, okay, we manipulate the concentration of sodium chloride solution. Okay, yeah. Responding variable we have products at anode. Okay, fixed variable we have we use the sodium chloride solution, or we can write type of electrode use, that is a carbon. Okay, C. Okay, so what is a hypothesis? We can write, okay, a hypothesis. Okay, so meaning that this one you can refer to the conversation from the student just now. Okay, so if concentrated sodium chloride solution is used, okay, so chlorine will be produced at anode during electrolysis. Okay, so meanwhile, when dilute sodium chloride solution is used, okay, oxygen gas will be produced at anode. Okay, yeah, so this is how we write our hypothesis in order to get 3 marks. Okay, so remember you must mention about 2 conditions. Here we need to use the concentrated sodium chloride, another one would be dilute sodium chloride. Okay, so normally you need to write both condition. Okay, next would be the material and the apparatus. Okay, so material first. So material we use is, okay, first one will be concentrated sodium chloride solution. Okay, another one will be dilute sodium chloride solution. Okay, after that we also need to have wooden splinter to test the oxygen, and then blue litmus paper to test the chlorine. Okay. Now for the apparatus. Okay, for the apparatus. Apparatus will be, okay, battery Okay, electrolytic cell. Okay, connecting wire. Okay, then test tubes, because we are going to collect the gas. Then after that we carbon electrodes. Okay, next we are going to list out the procedure. Okay, so we have to explain in details one by one how to conduct this experiment. Okay, so don't write the apparatus is set up as shown in the diagrams. So like this you will lose a lot of marks. Okay, so step 1, okay, we can fill the electrolytic cell with, okay, so first one we use the concentrated now, concentrated sodium chloride, okay, solution until half full. Okay, until, okay, so step number 2. Okay, so and we invert a test tube. Okay, fill with concentrated sodium chloride solution. Okay, at the anode, at the anode. Okay, because we want to see the products formed at the anode. Okay, after that we connect. Okay, connect the electrodes. Okay, to the battery. Okay, using connecting wires. Okay, then after that we can complete the circuit. Okay, then we collect the gas and test test the gas collected at the anode. Okay, then after that record the observation. Okay, then finally, okay, repeat step 1 to 6 using dilute, okay, sodium chloride solution. Okay, so normally steps, the last 2 steps will be the same whenever you need to explain the observation, or explain the procedure, record and repeat. Okay, now if you can list all the steps 1 to 7, you get score 3. If score 2, okay, you must be able to mention step 1, step 3, 6 and 7. You can get score 2. Then score 1, okay, at least you can mention idea of electrolysis. Okay, or step 1 and 3. Okay. So this is how you can score well in the procedure part. Okay, then last one will be the tabulation of data, will be F. Okay, tabulation of data, remember, must draw a table, must be a table. Okay, so actually it's quite simple. We can just use the MV and the RV. Okay, our MV is what? Is a concentration, right? Concentration of sodium chloride solution. Our RV will be products at anode, or easier, we just write observation. Okay, so here we can use okay, this one is a dilute, another one is concentrated. Okay, okay, so observation, we just leave it empty. It's like this. Okay, because you are planning the experiment. Okay, so that's all for the paper 3 for SBP trial paper. So if you have any question, you can write at the comment below, and then like this video and share with your friends. Thank you very much. Hi, welcome back to ChemTube channel. I'm Jaku Wong. Today we are going to look at MARA trial paper 3. Let's start. Okay, question 1. Diagram 1.1 and 1.2 shows two sets of experiments to determine the heat of displacement. Heat of displacement. Okay, conducted by a student. So experiment 1. Okay, we read the question carefully. So 50 cubic centimeter of 0.5 mole per cubic decimeter coupled to sulfate solution and the zinc powder. Okay, we see the temperature, initial temperature of the solution. Okay, here, okay, this diagram is clearer. Okay, so again, we have to determine the decimal place. So 110. So each scale represent 1 degree Celsius. So divide by 2, you'll get 0.5. So 0.5, 1 decimal place. So all the readings must be 1 decimal place. Okay, now we look into the reading here. So this one is 25, 26, 27. No? So we must read at the at the center there. So is 27.0. Okay. So before, so it's 27.0 degrees Celsius. Unit is given, so no need for you to write again. Okay, highest temperature is be 40 degrees Celsius. Okay, 40.0. Okay, then the change in temperature, so 40 minus 27, so it's 13.0. Okay. For experiment 2, now we see the volume 50, concentration 0.5. Okay, now using the copper 2 sulfate and the magnesium So here okay, so the temperature T1, T2 and T3. Okay, now this is how we record already. Okay, now construct a table that can be used to record the data. Okay, to record the data from both experiments. So construct a table, must be a table. Okay, so we can first one. Okay, we can use a different way to record the data. Okay, let's say temperature. Okay, we have two experiments, right? Okay, experiment. Okay, so we have experiment 1 and experiment 2. Okay, first one we need to see. Okay, we need to write initial temperature, okay, of copper 2 sulfate solution. Okay, I can put it here. So initial temperature is 27.0. Okay, this set 2 is T1, not given. Okay, next. Okay, highest temperature of, okay, mixture. Okay, this one is for T, this one is T2. Okay, then after that will be change in temperature. Okay, so this one is 13.0, this one is T3. Okay, so this is how we can get score 3, can score 3. Now, for the experiment, the manipulated variable MV, just now we know that is the type of metal used, right? Okay, or you can list out the magnesium and zinc. Okay, then the responding variable will be the heat of displacement. Okay, then fixed variable, okay, again volume and concentration of copper 2 sulfate solution. Okay, or another one you can write is the polystyrene cup now. Okay. So, okay, for the hypothesis, okay, our MV is the magnesium, right? Magnesium and zinc. Okay, so when or if we write when magnesium, okay, react with copper 2 sulfate solution, okay, the heat of displacement is higher than the reaction between zinc and copper 2 sulfate solution. Okay, so this is how we can write the hypothesis correctly. Okay, so state 2 observation in experiment 1 other than the change in temperature. So beside that, okay, what else you can observe? Okay, so experiment 1 is the zinc react with copper 2 sulfate, so it forms a zinc sulfate and the copper. Okay, so here actually, if the most obvious would be the temperature, but accept the change. So what can you observe is, okay, the copper actually is a brown solid, right? Okay, brown solid is formed. Okay, another one is copper 2 sulfate solution is blue color. So blue color, it turns to paler because it changed to the concentration of copper 2 ions decrease because it changed to copper metal. So we can write okay, and then another one will be the zinc. Zinc, what happens to zinc? Zinc will dissolve, also can become one of the observation. Okay, so you can write there are two observations, right? Okay, so first one we can write brown solid is formed. Okay, the second one we write okay, zinc powder dissolve. Okay, another one you can write the blue copper 2 sulfate solution becomes paler. Okay, paler. So this is how you can write your observation. So you can choose any two any two. Then observation, after the observation, give the corresponding for the answer. Okay, so just now we mentioned is we must be follow the one mentioned here. Brown solid is formed. So the brown solid is copper is formed. Okay, so number 2, zinc dissolve. Zinc dissolve meaning that hold on okay, zinc is dissolved meaning that zinc react, okay, or zinc is oxidized. Okay, zinc is oxidized. Okay, okay, because zinc is changed to zinc ions by release 2 electrons. These are under oxidation. No? Okay, number 3, you can mention concentration of copper 2 ions decreases. Okay, so any two inference, like say you choose which one, you must follow the one the correct inference. Okay, F, state the operational definition for heat of displacement. Okay, yeah, again heat of displacement, operational definition O and D, what you observe and what you do. Okay, so what you do, okay, the metal add into the solution, right, and then displace the metal from its solution, and then what should be observed? The temperature increase. Okay, so what we can write, okay, so the temperature rise when okay, when zinc or magnesium powder is added into copper 2 sulfate solution. Okay, to displace okay or to form 1 mole of copper. Okay, yeah. Then calculate the heat, the mass of the copper displaced. Okay, G, calculate the mass of the copper displaced in the experiment 1. Okay. So first we need to calculate the, first we write out the equation first. In experiment 1 is zinc react with copper 2 sulfate. So first source zinc sulfate and copper. Okay, so here zinc is in excess, so we need to calculate the number of mole for the copper 2 sulfate first. Okay, we use the MV over 1000. So the M is concentration is 0.5, V is 50 over 1000. So you get 0.025 mole. Okay, now we compare the number of mole for the 1 mole of copper to 1 mole of copper 2 sulfate to 1 mole of sulfur. So copper, 1 mole of copper. So the mole ratio will be the same. So mole ratio will be the same. Okay, so 1 mole of copper 2 sulfate produce 1 mole of copper. So 0.025 mole of copper 2 sulfate produce 0.025 mole of copper. Okay, so after that we can calculate the mass. The mass of copper used to be mole times molar mass of Cu. Okay, so mole is 0.025 times molar mass is 64. So you will get 1.6 gram of the copper is used in the reaction here. Okay, now diagram 1.3 show the result for the third experiment. Use the silver powder. Okay, silver powder. Okay. The initial temperature is 28. Highest temperature is T4. Okay, T4. So predict the highest temperature for the T4. Okay. So here, okay, is a tricky thing here. Okay, so you have to know silver. Okay, silver you put inside the copper 2 sulfate, right? Silver is less electropositive than copper, so it's not able to displace. Not able, so no reaction actually. So if no reaction, means that the highest temperature will remains the same, 28 degrees Celsius. Okay. So based on the diagrams, 1.2 state the relationship between the color of copper 2 sulfate with time. So 1.2 is the reaction between the magnesium with copper 2 sulfate. Okay, so it forms the magnesium sulfate and the copper. So copper 2 sulfate is being displaced, meaning that it will change to copper. So meaning that, okay, the blue solution, copper 2 solution will decrease decreases with time. Okay, yeah. meaning that it changed to copper metal already. Next, classify the following metal into more electropositive metal and less electropositive metal than copper. Okay, so here actually if you know the position in the electrochemical series, you know lah. Okay, so magnesium, yes, higher, aluminium higher, lead is higher, silver lower, okay, zinc higher, gold is lower. Okay, yeah, so meaning that we can write, we can make a table like this. Okay, so more electropositive, less electropositive. So more electropositive, we have magnesium, we have aluminium, we have zinc, we have lead. Okay, less electropositive, only two, silver and gold. Okay, so you can get score 3. If totally reverse, okay, will be score 1 only, score 1. Okay, for question number 2, diagram shows a conversation between two students about the product forms at the anode after electrolysis of potassium chloride solution. I found out this question is the same as the SBP. So when student A mentioned low concentration of potassium chloride solution, the gas release ignites the glowing wooden splinter. So this is the oxygen. Then another one is the chlorine gas. Okay, again, I think should be the same. So maybe, who knows, this question is quite popular. Will come out in the SPM this year. We don't know. Okay, don't spot the question. Okay, and then problem statement, and then until tabulation of data will be the same actually. So we revise one more time again. Okay, so first one, okay, problem statement. Okay, thus the concentration of potassium chloride solution affect products at anode during electrolysis. Okay, it asks a question. Okay, so B, our manipulator variable. Okay, so concentration of potassium chloride, potassium chloride solution. Okay, our RV will be products form and anode. Okay, fixed variable. Okay, right. Okay, type of electrons. Okay, or potassium chloride solution. Okay. Now next will be our hypothesis. Okay, if concentrated potassium chloride solution is used, okay, the product form, okay, we can just write chlorine is produced at A naught, huh? Okay, and if dilute potassium chloride solution is used, oxygen is produced at A naught. Okay, yeah. Okay, next one will be the material and the apparatus. So material used will be concentrated potassium chloride solution. Okay, then dilute potassium chloride solution. Okay, here if concentrated, you can put in a value, let's say 1 mole per cubic decimeter. For dilute, dilute must be less than 0.001. Let's say we put 0.0001 mole per cubic decimeter. Okay. Then after that, we need the apparatus. Okay, apparatus, we need the carbon electrodes. Okay, what else? Electrolytic cell, lytic cell. Okay, connecting wire. Okay, what else? Okay, we need battery. We need test tube. Okay, after that, okay, wooden splinter. Then blue laminated paper. Okay. Okay, after that we can write the procedure lah. Okay, the procedure. Okay, so first one, again, okay, fill the electrolytic cell with, okay, concentrated, okay, potassium chloride solution until half full. Okay, next, okay, invert a test tube, fill with concentrated potassium chloride solution on the anode, because we need to collect again. Okay, next we need to connect the electrodes to the battery using connecting wires. Okay, then after that, number 4, okay, complete the circuit. Okay, next, collect and test the gas release at anode. Okay, 6, okay, record the observation. Then finally, repeat step 1 to 6 using dilute potassium chloride solution. Okay, so remember, so score 3, you must make sure that you can complete all the 7 steps. Okay, score 2 would be step 1, 3, 6 and 7. Score 1, idea of electrolysis. Okay, let's say step 1 and step 3. Okay, then finally is the tabulation of data. Okay, F. So tabulation of data must be a table. Okay, must be a table. So okay, draw a table. Our MV is a concentration of potassium chloride solution. Okay, then the RV is the product as at N naught, so we can also write observation. Okay, so concentration, first one we use concentrated, another one we use the dilute. Okay, yeah, so observation we can leave it empty because you are planning the experiment. Okay, so that's all for the MARA paper 3 trial paper. If you have any question, you can leave at the comment below. Like this video and then share this video with your friends. Thank you very much.